The topic here is the u-substitution for integrals. Again, we're looking at the definition of the power rule for integrals. Integral of un du is equal to un plus 1 over n plus 1. So let's do example 8. We need to evaluate the integral of secant squared x over tangent to the fifth x dx. So first, let's rewrite the integrals. Secant squared x over tangent to the 5x dx. This is the same thing as secant squared x tangent negative 5x, right? We mean move tangent to the numerator, the exponents becomes negative, and then dx. Now here we have two options. By the way, we can rewrite this as integral of secant squared x. Tangent negative 5, it just means tangent x, even though we write it that way, this is what we mean with that, to the negative 5 dx, right? So we have two options here. We can let u equal tangent x, or u equal secant. The problem, if we let u equal secant x, when we do du, if we let u equal secant x, if we let du will be equal secant tangent dx, and then we have a problem with this extra tangent. So it's better, even though we have two options, and you can try both, one of them would not work and then this will work. If we let u equal tangent, we know that the du is just a secant squared, derivative of tangent secant squared, so this has come easy. So let u, substitution will be u equal tangent x. This means that du is equal secant squared x dx. So dx will be equal du over secant squared. Now, like always, we need this part and we need this part. So now this is going to be equal integral secant squared. Well, let's leave it. So secant squared x. Now I know this is a u, so u to the negative 5, tangent x is u, and my dx is right here. It's a du over secant squared of x. Now here, just simplify secant squared, and this becomes an easy integral. U negative 5 du. Now use the power rule for integrals. U negative 5 plus 1 is negative 4 over negative 4 plus 1 plus c constant. This is going to be equal negative 1 over 4 u to the 4th. Why did I move u to negative 4 to the bottom? Plus some constant, and then replace the u by its value, which is tangent x. So this is going to be equal negative 1 over 4 tangent 4 of x plus some constant. So we're done with this example. Now for example 9, we're trying to do integral of secant x cubed tangent x. In this case, I mean, you can, if we rewrite this, you'll see, if we rewrite this, secant x means secant x, that's what we mean with cube, everything to the third, tangent x dx. This is simple because we have only one option. Whatever is between parentheses has to be equal to u. So if we let u equal secant x, now du, derivative of u with respect to x is what? Derivative of secant is secant tangent. And don't forget the dx. And then my dx is going to be equal du over secant tangent. So we need this and we need that. So if we do that, we'll get integral. We know secant is u, so u, I'm using this, so this is u cubed, tangent of x, and I know my dx is right here, which is equal du over secant tangent. Now, tangent goes with the tangent, which is good, which is equal to u cubed du over secant x. Now secant x, I have a problem with secant x, but if you look here, secant x is just a u. So now I'm going to go one more step. This is a u cube du over u, which is from here, it's pretty easy. Integral u cubed divided by u is u squared du, which is u, 2 plus 1 is 3 over 3 plus constant, and then substituting back into u. The u we said is secant x, so secant cube of x over, well, it's not integral, over 3 plus constants. So that would be our, that would be the integral. Is equal secant x cube of x over 3 plus c. And that's it for these examples.